Assalamualaikum everyone. Today, we want to present and also to discuss about our last assignment that has been given from our madam. Without wasting any time, I will introduce you all my group members. Okay, so first, we start from Muhammad Haris bin Rosli, Anis Adila binti Abdul Fattah is me, Duhai Muhammad ZM, and last, Izati Nurina Anur binti Abdul Latif. We have been given these three questions to solve, and Alhamdulillah we can provide good cooperation in completing all the questions given. We have also able to complete this discussion video perfectly. And last, we hope all the discussion and explanation from us and others are clear and easy to understand. Thank you.
Thank you to you, Anis, for the introduction. Hi and Assalamualaikum to all of you. My name is Muhammad Haris bin Rosli and my matric number is B00 B011920018. I will explain to you guys the first question. Based on the question that need us to design the spherical tank to hold water for the small village in the developing country. The volume of liquid can be computed as V equal to pi h2, where V equal volume, h is depth, water in tank, and r is tank radius. In r in if r equal to 3 meter, what depth must the tank be filled to so that it's hold in 30 meter? Use the diameter representation. Okay, determine the approximate relative error after each iteration. Note that the interaction guys of R will always converge. F. Okay, this is apa ni? This is a formula. F equal to pi r h square minus pi 3h3 minus v. Okay, I will expand this formula. Okay, use the substitution parameter value. Okay, so I get the HO is 2.0610. Okay, and I make a percent of HO. Okay, I will get 45.56%. This is a latest formula. I will use a latest formula to calculate the H2. Okay, I get the 2.0270. Okay, I calculate the percent of error. Okay, I get 1.76%. Okay, I calculate the H3 and I get the 2.0269, and last I calculate the percent of error and I get 0.005%. Okay, thank you for me. Assalamualaikum warahmatullahi wabarakatuh.
Hello, my name is Muhammad Doher and I will be answering question 1b from the math assignment. As we can see here in the question, it says the main equation can be written for a rectangular open channel as we notice there, where Q here as it's given here, we are given the requirements to find the derivative using fixed points. Can solve this equation for h given q equal 5 and s equals 0.002, b equal 20, and n equal 0.03. Prove that the scheme converges for all initial gases greater than or equal to 0. Now to solve this, we need to make the first equation as our first equation, and after that for h with known values of q, s, and b and n using fixed point iteration method, we must reformulate the problem. Let's define fh equal q minus the square root of s ph all the power of 5 over 3 all over and b plus 2h power of 2 over 3. One way of looking at the problem of solving the equation star is finding the root function f. In the fixed simple method, we are searching for h such that gh equal h. Therefore, we must probably define function g such that fx equals 0, so gh equal h. So here, as we can observe from the equation star, more thoroughly rephrase it after that. Then after we rephrase it, in the second step we add single out power of h, and after that, after we get the formula, therefore we can define it as gh equal, and this equation is what we got. To prove convergence for all initial gases greater or equal to 0, we must show that gh is less than 1 for h greater or equal 0. So we easily calculate by getting the derivative of the equation, our first equation that we get from here, gh, and after that we substitute the number that we know from the question, it's already given, and we find the g prime h, and like that we can find the answer. Therefore, the fixed point method converges for all h greater or equal 0, and it converges to h equal roughly 0.7023. Now, to test the result by performing iteration given by 6.2 using initial gases h equal 5, so now we get the first derivative by saying h1 equal gh0, and we find g5 from the first what we got from gh plus 1, and then we calculate from the formula here and we get the answer. And after that we get the h2, which is the iterative number 2, the second iterative, and then we find the third iterative, which is 0.004, and after that obviously we can get derivative, fourth derivative here, and we get the answer, which is minus 0.0097. So, and we see that the h is roughly 0.7023. That's all, and thank you.
Assalamualaikum. My name is Izzati Nurina An-Nur binti Abdul Latif, B012010104. Today I will solve question 2. So, the question given is as shown in this slide. The question asks us to find the maximum and minimum values of magnitude of velocity and acceleration. Let's see how I solve it. RT equal 3 cos Tj plus 2 sin Tk is the expression given. We can get the expression of velocity by take the derivative of this expression. And we will get negative 3 sin Tj plus 2 cos Tk. For acceleration, we take the derivative of velocity and we will get this, negative 3 cos Tj minus 2 sin Tk. After that, we can figure out magnitude of velocity square by simply do this. And we will get 9 sin square t plus 4 cos square t. Same goes to acceleration. We put the expression into this equation and the magnitude of acceleration square that we get is 9 cos square t plus 4 sin square t. After that, we can take the derivative of magnitude v square, and we will get 10 sin t cos t. 10 sin t cos t is equal to 0 when we put t equal to 0, pi over 2, pi, and 3 pi over 2. If we plug in 0 in 9 sin square t plus 4 cos square t, we will get the magnitude of velocity square equal to 4. So the magnitude of velocity is equal to 2. Same goes when we put pi. We also get magnitude of velocity square equal to 4 and the magnitude of velocity equal to 2. When we put pi over 2 and 3 pi over 2, we get the magnitude of velocity square equal to 9. So the magnitude of velocity for both is equal to 3. So magnitude of velocity minimum is equal to 2 when t equal to 0 and pi, while magnitude of velocity maximum is 3 when t equal to pi over 2 and 3 pi over 2. For acceleration, we can take the derivative of magnitude acceleration square and we get 10 sin t cos t. It is the same like velocity. 10 sin t cos t is equal to 0 when we put t equal to pi over 2, pi, and 3 pi over 2. If we plug in 0 in 9 cos square t plus 4 sin square t, we will get the magnitude of acceleration square equal to 9. So the magnitude of acceleration is equal to 3. Same goes when we put pi. We get magnitude of acceleration is also equal to 3. When we put pi over 2 and 3 pi over 2, we get the magnitude of acceleration square is 4 and the magnitude of acceleration is 2. So the magnitude of acceleration for both is equal to 2. So magnitude of acceleration minimum is 2 when t equal to pi over 2 and 3 pi over 2, while magnitude of acceleration maximum is 3 when t equal to 0 and pi. So we can conclude that when velocity is maximum, the acceleration is minimum, and when velocity is minimum, the acceleration is maximum.
That's all from us. Thank you.